Hello everyone, we'll be studying pressure in fluids and atmospheric pressure. Okay, and we will understand thrust and pressure first. So let us understand what is thrust. The force that is applied on a surface in a direction perpendicular or normal to the surface, that is called thrust. Okay, now you remember that thrust will be in one direction. Like for example, the push of the rocket, that is in one direction, and that force that pushes the rocket up is the thrust. Now thrust can also be said as a force or a push when a system pushes or accelerates mass in one direction. There is a thrust or force just as large in the opposite direction. Okay, remember that it will be same in the opposite direction. Thrust is used to describe how strongly an engine pushes. Like you can see on the right hand side of your screen, describe how strongly an engine pushes, right? How much is the thrust to push the rocket up? Let's see the unit of thrust. It is measured in the same unit as of force. The SI unit of thrust is Newton, and the CGS unit of thrust is dyne, where 1 Newton is equal to 10 to the power 5 dyne. Now let us understand about pressure. It is symbolized by lowercase p or uppercase P. It is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Now remember, this pressure also depends on the area. It can also be said that pressure is a push or force against a surface, and pressure is a weight of the air in the Earth's atmosphere, right? The weight of the air in the Earth's atmosphere also is a pressure. Like for example, there is a force of air on the Earth's atmosphere, or any force applied on a particular area experiences a pressure. Let's see the unit of pressure. Unit of pressure is derived from the units of both force and area, as pressure P is equal to force by area, and the SI unit of pressure is Newton per square meter, okay, or symbolized as Nm to the power minus 2, derived from the unit of both force or thrust, Newton, and from the unit of area, meter square. Okay, that's why it is Newton per square meter. The CGS unit of pressure is dyne centimeter square. Now this is something that I want you to remember, the symbol that is used here. Pressure exerted by liquid column, P is equal to H. That symbol that you see here, I have put an arrow sign so that you understand it is known as rho, and that represents the density. Okay, and this expression or equation that you're seeing is pressure, is of pressure. The pressure exerted by liquid depends on the height of the liquid column. More height of the liquid column, in the depth, the pressure will be more. And we know that pressure can also be written as P is equal to H rho G, where H is the height and rho represents the density, and G represents the gravity or acceleration due to gravity. Now as the height increases, pressure will also increase. On the left hand side of your screen you will see a diagram to understand it much better. Okay, let us see what this diagram represents. In this diagram you see that there's a vessel. Okay, a vessel containing a liquid of density rho. Now this liquid is stationary, it's not moving, and H is the depth. Okay, H represents the depth, and we have to find out the pressure at the depth H. There will be pressure at the circular surface, that is PQ. I'm just circling it so that you know what I'm talking about. Now there is a pressure here due to the weight of the liquid above PQ. Okay, and XY represents the free surface of the liquid. Okay, there is not much pressure over there in XY. And PQRS is a cylinder inside the container, okay, where liquid is kept. And PQRS also contains liquid of height h with PQ as the base and RS lying on the free surface xy of the liquid. Okay, I hope you have understood that diagram. Now let us understand what we can derive from that, what we can understand from that. Thrust exerted on the surface PQ. Okay, the thrust, the force that is exerted on the surface PQ is equal to the weight of the liquid column PQRS. Okay, weight of the liquid column. It's not about the empty container, empty vessel PQRS. It's talking about it is equal to the weight of the liquid column PQRS, which is equal to volume of liquid column PQRS into density into gravity, acceleration due to gravity. Okay, which is equal to area of base PQ into height into density into G. Alright, where area of base PQ is represented by A, height is h, rho represents the density, G represents the acceleration due to gravity. Now when we remove the brackets, we will get it as A into h into density into gravity. Now this thrust or force is exerted where on the surface PQ of area A. Let me just shade that part so that you understand that there is a pressure there, and that's what we have to find, how much thrust, how much pressure is exerted on that point. Now pressure is equal to thrust on surface by area of surface. Okay, and thrust of surface we have already seen, that is area into height into density into gravity, area of the base PQ, that's what A represents, divided by area of the surface is A. Now when we write it as a division form, A into h into density into G by A, now these A's can be cancelled, leaving h, rho and G. So by this we understand that pressure is equal to height into density into gravity. I hope you have understood this. Let's see the factors that affect the pressure at a point in a liquid. At different point in a liquid, there will be different pressure. The factors, the first factor is depth of the point. Deeper the point, more is the pressure. The second is density of the liquid, represented by rho, and the third factor is acceleration due to gravity. I hope you have understood this. You can go back through the video and see it again to understand it much better, and keep studying and keep learning.